So, hello everyone. Thanks for the quick introduction. So, thanks for joining this session, and we will discuss about how we can enforce the API standards for Kubernetes at a scale. So, just a quick question: how many of you actually using Kubernetes operator at scale, and how many of you actually having the pain of fixing the CRDs at the production environment? So the current challenge is that if we are working on a Kubernetes production environment and the multiple operators are getting managed by the different teams, then how will you tackle that challenge? So let me first give a small introduction about the operators. So operators are basically a way to manage or automate your application which are running inside the Kubernetes. And these operators are consist of the config map, the CRDs, and as well as stateful set and other components as well. So CRD stand for the custom resource definition. So if you are working in the Kubernetes environment, there are default components like the pod, replica set. But in case you want to extend the API, you want to use some new custom element in which, so you will basically use the CRD. That's the YAML file. So you choose that file, you will create the custom resources. So as you can see, there are the different teams that are managing the operators, and these are the different YAML file, which are the custom resource definition file. So the problem is that if we increase the multiple operators, so we have to tackle and we have to manage different drift in the structure and semantics. So what do you mean by that? So if some member in team A changes the pod size from the int 32 to a pointer of integer 32, and some member in team B added some of the validation inconsistently, and the team C, so some new intern joined in that team C, and he has no idea about the documentation or workflow, so he did nothing. So that result in a schema mismatch, so which will be obviously a problem for the deployment failure, and this will result in a production downtime, and obviously will increase the developer frustration. So how to tackle that problem? So we need a unified way of using the API governance in our solution. So basically we will use the three pillars of our solution. So first one is the OpenAPI. So we will use the consistent validation standard for that. And second one is Arazzo. So we will try to maintain a workflow for that. The last part is the overlay. So we will use some compliance and rule for the deterministic enforcement. So let's talk about the OpenAPI specification. So we all are aware that it's a standard specification for describing your RESTful API in a more machine readable way. So basically it comes in a YAML or JSON format, depends on your use cases. And you can define the API endpoints, the authentication method, and as well as the request and response structure. Use cases are simple, so you can generate a documentation with the help of it, the client generation, and do the API validation part. So in the month of August, just a few months ago, so OpenAPI 3.2 is launched. So there are some of the new features that is highlighted on the screen. So I will just give a quick introduction about it. So they have introduced the new query method and some of the HTTP verb that is called as additional operation for defining your custom HTTP verb, and as well as increasing flexibility in the API design. So it supports the OAuth authentication, and as well as they provided some of the easier integration like the RBAC, etc. And they come with a hierarchical tag. So basically we have normal tagging, but in the hierarchical tag, so you can see there is a parent and a child relationship that will help you to identify best of the model management. Okay, now coming back towards problem. So as you can see that you need to convert CRDs to the OpenAPI. So basically there are actually three methods. So first one is the Kubernetes cloud native friendly method. So basically if you have installed the operator SDK for generating the operators, so you can use the controller gen. You just need to run the make manifest command, and it will embed the OpenAPI schema into your CRDs. Now you have to run the kubectl get CRD command, and it will run the JQ command, so you will get the JSON schema of your OpenAPI. There are two tools available as well. So one is the CRD to OpenAPI, and another one is OpenAPI Gen. So these are actually available in the Go format. So if you are working on a Go language, so basically operator generation is a Go friendly native language. So you can install these packages with the help of Go, and you need to run the command. So it will convert the CRDs into the OpenAPI YAML. So as you can see, we are using the kube builder for the API marker validation, and we have used the OpenAPI as a single source of truth. So it has converted our OpenAPI schema into this format. Now, once you have your OpenAPI YAMLs ready, so you need to generate a proper documentation with the help of it. So you can use a Swagger editor, that's the best UI available, and you just need to put your YAML into it. So as you can see that the first operator was the Memcache API, so it has generated all the REST API point in a proper and readable format. The good part is about that is it is generated schema as well. So on this side you can see the Memcache spec has the three fields, the port size, the port number, and as well other resources. So you can see we initially started with some of the Go types and we have converted into the OpenAPI schema. So this is basically a more readable format. So initially it was defined in such format. Now you can see you have a better information on the screen. So it has a minimum maximum number of pods and default is 3 for the pods defined here. Now what are the key benefits of using this approach? So we have initially discussed when some member in the team changes the pod size from integer 32, so it creates some problem. Now once that problem happens, so you can see the changes are already reflected in the specification. The good part is that the OpenAPI schema has a different field definition which were missing in the CRD file, and some of the validation rule and information are actually well maintained. Okay, now coming towards the second part of our solution, that's Arazzo. So Arazzo is another specification for describing the sequence of your OpenAPI calls, and it will describe an approach. So if you have a business use case, so you can convert that business use case into a proper oriented workflow. The good part is that it's a programmatically readable format. So it will tell you that how to increase the developer experience. So we'll talk about some of the specification architecture for the Arazzo documentation. So as you can see, the first part is the info. So that contains the metadata about your documentation. And here's the YAML format field. So you can see the title, version, description are already mentioned in that YAML format. So the next part is the source description. So this is basically used if you want to cross-reference one or more OpenAPI in the workflow. As you can see, we have two fields in the source description. So first one is the Memcache API, and that references the OpenAPI YAML, and second one is the Kubernetes API. So that is using the default Kubernetes APIs. The workflow are actually divided in some of the parts, and it will describe how you can use one or more APIs. So the first part is the input. So input is basically a JSON object schema. So that will represent how your workflow will operate it. So as you can see, under the properties, we have instance name, we have the environment, so we can run on the development stage production, and the initial size of the pod, like minimum, maximum is specified here. Next part is the steps. So it will represent a call to your OpenAPI operation. So these are different fields, like if you want to validate the configuration, you can define in the step ID, and you have to provide the input. And on the basis of the success criteria, if the status code is 200, so it will show you success. Otherwise, it will result in a failure. And you have to run another step for the validation error to handle this error. Next part is the output. So you can consider output as a friendly map between the dynamic output value for a workflow. So if the workflow name is too long, then you can define your name and it will be easy for you. So there are some reusable objects are present inside the component, so you can reuse on the basis of your requirement. There is an evaluation rule which defines for the success and failure. So if the status code is 200, which is success, otherwise if the code is less than 300, it will result in a failure. There are two reusable components which are the part of reusable objects are present. So you can see that the request body is there and payload replacement is present in there. We are not using that, so we won't discuss much about it. Okay, so once you have your Arazzo documentation is available, so you can integrate into CI pipeline as well. So here is the workflow, or you can consider as a flow diagram. So what I did, so when you have the Arazzo documentation ready, so there is a Mermaid UI. So you can put all the information inside that UI and it will convert the well-defined flow diagram for your use cases. So it will look like this. Once you will validate the CRD, you can apply the overlay, which we'll discuss in the upcoming slides, and you can validate the cluster as well. So this was the declarative API workflow, and you can define the multiple steps within that workflow. So let's talk about the tooling part. So we have used the Spectral CLI. So it was available in the NPM and as well as the CLI for the validation and linting part. So all you need to define the rule set and you are ready to go with it. So the key benefits are it's a reproducible workflow. The multiple teams can work on it with the help of consistency, and there are some validated automation pipelines available. So you can automatically run this pipeline with the help of CI/CD as per your choice. And the last but not least, it is a code generation and a document tool for communication. So initially we were using the 1,000 line of codes which were written in a shell script. And then after using the Arazzo, it has converted our shell script code into the Arazzo documentation. So is it easy to understand? It is easy to solve any issue, solve any error with the help of this workflow. All right. So the last part of our solution is overlay. So overlays are defined as a modification specification. So that will transform your OpenAPI YAML based on the different environment. For example, you want to use any production environment, stage development, and you want to apply any organization policies, compliance, then you can do that. So the good part is that instead of just changing the original OPI YAML format, so it will create changes in a separate file. It will fix the schema inconsistency, depends on your environment. So if you are using production, so it will fix the consistency according to that. For the dev, it will be different. And as well as there are some enhanced security part, the authentication and rate limiting available as well. Okay, so here's the architecture. So you have your OpenAPI YAML file ready, and you just have to apply the overlay on the top of it. So based on your environment. So we'll be using the Speakeasy tool for the modification or doing any changes in your SDK generation file. So I will discuss about it, how you can generate the SDK for it. So there is one more tool called Bump CLI, so that will use for the version management. And based on your requirement, you can generate the different SDK based on the different prod, stage, etc. So on the screen you can see we are using the Speakeasy. That's the CLI tool is available, or you can use the NPM package as well. So you just need to run this command, overlay apply, and you will give the OpenAPI YAML as an input, and on the basis of which you will generate the production overlay YAML file. You can apply linting as well with the help of Speakeasy, and it will give you a well-formatted YAML file. So the use cases are you can apply the minimum validation rule. You no need to go deep into that, and you can add the security requirement as well as that depends on your organization. So if they want to block any IP address, if they want to block any firewall, etc., you can do with the help of it. It will reduce the error responses, and you can change your organization policies with the help of it. So as you can see on the screen, so the overlay generated in the form of environment specific. So as you can see, so we have a different environment here. So for the development, it is having a pod size of minimum 1 to 10. For the production, it is going for 3 to 50. And for the other environment, it is going for 1 to 100. So at the start of this session, I have discussed that it is using the integer 32, and someone changes from int 32 to a pointer integer 32, so which were causing some inconsistency. So this got fixed by using this overlay file. And if someone using a wrong port, so then it will fix the same issue with the help of it. So before the overlay, there was this problem, and after it, we are good to go. So you can do a CI/CD integration with the help of this overlay. So you can manage the GitHub tool or any other tool as per your choice. So it supports the multi-environment, so you can do on the basis of that, and some conditional rules are available. For example, you want to put a size construct for the pod, you can do that. So there has to be some replicas or resources that has to be constant, so you can define in the conditional rule as well. Okay, so what are the advantages of using this approach? So before that, we were having a lot of validation error. So after using this, we are not having that much of error, and it can give you a faster deployment cycle. So team can focus on the business logic instead of just fixing the validation issues. And if you onboard any new developer, so you have a very well documented structure, so it will be easy for them. So they can just follow the documentation and go with the help of it. The security policies are easy to apply, and we have seen the consistency across all the CRDs file. So this was the overall structure. So in a nutshell, if you are using these three technologies, so it will result in a success. So if some developer commit any CRD changes, so it will automatically triggers the workflow, and it will generate the OpenAPI schema. So once you apply the overlay patches with the help of this workflow, so it will provide the validation against your cluster, and you can decide you have to deploy or reject it. So the implementation phase was divided into three parts: the foundation, rollout, and scale. So the phase one was foundation. So you can apply edits to your existing CRDs file, and you can have overlay rules which can be discussed within your team, within your org, and then you can create a Arazzo workflow on the basis of that. Second phase is rollout phase. So you can start the changes single repository, no need to create multiple repositories. You can train your first team, not the multiple teams within your organization, and based on the feedback received by that team, you can further implement it. Third, last part is the scale. So once everything goes in a positive manner, everything is in the right way, so you can roll out the update to all of the teams, and you can apply the advanced overlay rules. And if everything is right, you can just integrate with the CI/CD. Things that you should know. So the technical implementation part is the easy. You can use any tech. Nowadays, every day new tech is getting launched. But getting your team members ready to adopt this new process is harder because of their attitude and whatever you can call it. So we should focus on making our life easier, not the harder. And whatever you are applying in your org or any tech, so it should be feedback driven, and it should have a good result as well. So this is one of my favorite quote. So that was written by me only a few days ago. So tech is only 30% of the solution. The 70% part is the management and the team adoption. So as I said earlier, it's the attitude of your team members. All right. So this was the end of the presentation. And so I am on GitHub and LinkedIn as well. So if you find it useful and you want to connect with me, then you can scan the QR. Yeah. Thank you all. Thank you for attending this session.